Okay, good evening, and here we are, part 7. Can't believe we've got this far already. Can't believe it's taking me this long to do this radio. What can I say? Apart from, we've had some family issues, we've had some problems, and without going into details, my health isn't that good at the moment, so things haven't been moving as quickly as they should have. But that's not your problem. Your problem is this radio. And what have I done so far? Well, in part 5, we did the power supply, and that's now done. Part 6, found the other Jonell radio, and I took nearly 100 odd photos. So where have I got with this? Well, we did the power supply, and I've started to work through, and as you can see, I've been checking the components, and at the moment I'm working around the output valve. And if I get my schematic, and this will probably swamp out the camera above it, looks blinking awful, but there we go. What I've done is ignore the power supply section for the moment, because I've got a separate drawing for that which I've made. What I've done here is I've checked where the power comes in, and in fact I've got to fill that in because we have both those capacitors in place. This is the trouble when you're actually trying to work over an open chassis. You haven't got anything to push against, as I keep telling the wife. Right. Okay, so here we go. There's your power comes in from your rectifier. So this is the B plus line. It comes in, goes through the choke here, and then comes out at this side by the other capacitor. And then all of this, although it's actually drawn as separate lines, this is actually a single point. This one, and this one. These are all a single point. And if I move this to one side here, then if I turn that so that we can all see it, I'll squish those wires flat. So what we've got here is we've got this single point, which actually is here. This is actually the input side here to the output transformer. This is the output transformer here, T1, and that goes as well as through to the valve along here. This, I've marked the pins here because I wasn't sure myself, and I'm still trying to remember which valves have what pins. Here there's an extra 47 ohm resistor, but that leads in to pin 3 here, the anode of this valve. Now the only reason I'm thinking that this was here is because the resistance of this coil wasn't high enough to put a decent load on the 6v6. So if you can imagine that that is a resistance, because obviously here we're all at DC, this is acting as a resistance, then this here would have an extra resistor in line. It's only 50 ohms, well 47 ohms. It's a very small resistance, which I do wonder why it's there, unless it's there as some form of fusible link in case the valve goes open, or in case somebody shorts out the output or something like that, and it's designed to burn out before the transformer. That's the only thing I can think of. So yeah, going through it, we've got here, we go to the anode of the valve, which is here, which if I just poke the pencil in, which is this one here. Pin 4, which is grid 2 on the 6v6, goes straight up to the B plus line. Now that's this one here, which goes to that point there, which is again here. So this point is the same as this point, which is the same as this point. So all of these, although they are all individual markings on a diagram, these are all a single point. So that's how come I've managed to fill that lot in. Now, I've not worked past this 50k, which is the resistor down here. And what I've done for the tone is, rather than repair the very flaky switch, what I've done is I've also taken off the anode of the valve. I've actually taken the output through the capacitor, and I'm going to put in a variable resistor, which is this capacitor here. This is the 50 nanofarads on the circuit diagram. I've got a 47 nanofarads in there, which is perfectly good. The thing about this capacitor is one that you have to be careful of. You are coming straight off the B plus line, so it's got to be rated at least what you expect out the B plus line. Now I'm expecting the B plus to be in the region of 250 volts or so. So here I've got a 630 volt capacitor in place, because that's what I have in stock. So that's why I've stopped there, again because I haven't coloured this in, because I haven't got this resistor. Now where I was working on was pin 5, which is grid 1 on the 6v6, which is actually coupled, which is actually the input basically from the previous stage. And here's the capacitor coupling in, so you know, a 10 nanofarad capacitor. And also pin 8. Now originally this radio didn't seem to have much of a bias for the output valve, but when I look through the circuit here, and this is where I haven't finished going through this bit, this pin, this resistor here was connected to pin 8, which is the cathode of the 6v6, and that goes through a 330 ohm resistor to ground. Well, what we have here is we have, if I read this right, 270, so that's a 270 ohm resistor going to ground at this point here, which actually follows the wiring there, that ground point there to there. But no capacitor. There doesn't seem to be a capacitor from there to there. Now maybe I've already taken it out. Maybe it was one of those that wasn't particularly healthy, didn't look in good condition, or it was one of those de Billier cans. Either way, there isn't a capacitor there, so I'm going to have to fit in a 25 microfarad capacitor. It doesn't need to be particularly high voltage because it is only a cathode bias capacitor. I think I've got something like, 25 30 volt capacitor. If I've got an axial in something different, then that's what I'll put in there, but I'll try and keep it sort of in the style. Yeah, as you notice, I'm not using your typical vintage components. I'm using brand new components pretty much for everything, because I want it to work. This one has been butchered so much that I'm not particularly fussed about its originality. The other one, on the other hand, is fairly original, so that one will get treated slightly different, but this one, because it has been butchered, I'm not frightened of doing the tone mod. I'm not frightened of doing this capacitor here as a bypass, and of modifying the power supply completely. Yeah, there we go. Hopefully that's visible. What I've done with the power supply to draw it out, rather than the original what's on the circuit diagram that you can't see at the moment, I've drawn it out here. You've got, basically, it comes in, it's only a single pole switch because that's all that's fitted on this particular pot. So that's the AC mains. It comes out, you've got a 6.3 volt heater line which runs the two heaters of the 6x5 rectifier. The 250 volts comes out, and between here and here you have the two diodes, here and here, and that continues on to this pin and this pin of the rectifier to give the to turn this effectively into a full bridge rectifier. So if you had this as pure solid state, what you would end up with is let me just draw it quickly. You'd have draw a square, and then you'd have one diode here, then you'd have another diode here, and then again you'd have, so you'd have your diodes here. This would be your, the plus is here, this is the minus, and this is your AC, and this is your AC. That's how it works. I'm brain going befuddled. So effectively what we've done here is this pair of diodes is this pair here. The two diodes in the rectifier tube are these two here. So all we've done is we've made a bridge rectifier with a tube and two silicon diodes, and that will give us our B plus there. Seemed a natural solution to a transformer that doesn't have a center tap. Obviously if I had a center tap, the center tap would just go straight to the chassis, these two wouldn't be here, and these would just go to the diodes, and this would act as a full wave rectifier by itself. So that's where we are, and I could sit here and I could watch, you could watch me soldering or getting components out of a box, but I think this is more realistic. I'm sitting here scratching my head. I've been at this for sort of 2 or 3 hours tonight, just going through stage by stage, working out what components are actually going where they're. Let's take these out of the way so that you can see the chassis again. So as I say, I was working out, where do I do that? I put in the cable that the live mains will come in on. I haven't put any mains cable in here yet, simply because it will just get in the way if I put a mains cable in at this point. So yeah, I'm gradually working my way through this, and hopefully the next time you see it, instead of me working on valve 4, I might be down to valve 2 or valve 3, valve 3, valve 2, or even as far as valve 1. Obviously I've got to sort out this bit. All of these old components will have to go, or certainly these two will be going. I haven't yet found one of these actually reading correctly, so I have been taking them out, and I'm very surprised at these mica capacitors that are going doolally. I'll be honest, I haven't put them on my leakage checker yet, but they're not reading any sort of value that makes any sense. So I've been sort of, the ones that were here and here to the tone control, I've got them out there. There we are, there's one of them. There's the two that went to the tone stack thing. That one's reading 50 picofarads, and that's actually got a bit of original heat shrinking on it, or cable sleeving on it, same style as the other radio. This black stuff, however, I don't know, I don't think this is original. I think this has been put on by a later engineer, and there's a lot of this black stuff in here, but there's also some of the original clear stuff which is evident in the other radio. So this has been heavily butchered. This is original. This is what was originally in the set, this cloth covering type cable. So yeah, I'm still first of all trying to decode what somebody else has done, and I'm also then trying to put it right. And as I say, the way I'm going through it is I'm doing it via the circuit diagram and just tracing it through. Let's bring it back again. Just going through step by step. I'm working on one valve at a time so that this bit right, where does this go? This connects to here and here and here. What have we got in the set? And I'm matching these lines up with what we've got in the set and just following them through, which is why this red wire is sort of hanging out. This actually goes over to here where the 220 ohm resistor is, which is this resistor here, which will actually be the next bit, but I'm just checking before I put it in that this capacitor will connect to the grid of the output tube, and that this resistor is in place. Now the ones that were in that position don't read anywhere near 220k. These are the two I took out. That one reads, you know, about 130k, and this one reads about half a meg, which for something that's yellow and I can't see a spot, so let's assume yellow, purple, yellow, you know, 470k, it's within tolerance, but I've got to find out where that originally should go, because the nearest 500k to here is actually down here, and that's the volume control, so it's not that one. Is it this 3k here off valve? You know, I'm not going to speculate, I'm just going to work through it methodically, otherwise we'll just get into a mess. So anyway, thanks very much for watching, and hopefully you'll stick around and this isn't getting too boring for you. I'm trying to keep the videos short and sweet, and not going for my marathon 45-minute videos of watching me solder something from start to finish. So I hope this has been good for you. We'll see you again for the next part. Have fun and take care and look after yourselves. Bye for now.